Hi, Srivalli.
Hi, Shanti.
So, what is your demo today for AIOps automation?
So today's demo is incident database creation in Azure. So this is part of transforming IT operations project. We already discussed two other phases before this. We discussed the importance of using AI ops. In IT operations. And we also discussed solution, um, the solution demo. I also gave the solution demo for implementing
Okay,
AI
yeah,
ops. So this
correct.
one is part of data pre-preparation. When we do model training, we need to do the data pre-preparation. For that, we have to create our own test data. So this
Yeah,
incident,
because you are not doing live project, you are doing a simulation.
yeah,
So, you are creating your own
yeah.
database.
So that is
Okay,
what this is.
yeah, please go ahead.
Hi, I'm Srivalli. I have about 16 years of experience in IT industry. My latest experience being at Microsoft Redmond. Today, I'm here to demo Incidents DB creation in Azure. This is phase 3 of transforming IT operations. We have already discussed two other phases of this project. Um, so let's begin. Let's start with the agenda. Um, First, we are going to discuss test data creation. Test data creation in the sense, what is our data requirement and how our data looks like in the database. And then next, we are going to discuss uploading into Azure SQL DB. I'm going to show this manually first, and then we will go through a script that automates the creating of SQL DB instance on Azure, as well as um, um, uploads the data into the SQL DB. It creates the schema. And then I'm going to show you a simple command to destroy the SQL DB. And then we'll discuss uploading the test data into Cosmos DB. And then a simple command to destroy the Cosmos DB on Azure. Test data creation, data requirements. 4 tables are required in this project. We require 4 tables. Categories table, users table, incidents table, and user queries table. This is the incident DB schema. Categories table has category ID, category name, subcategory ID, subcategory name, and subcategory ID is the primary key here. And then there is users table. These users are the L1, L2 engineers who use the chatbot. So their details are there, and ID is the ID of the column for primary key. And incidents table has along with the other columns, it has the incident description, so that when L1, L2 receives a ticket, they have to log the incident description. And then user queries table has a query. The query column is the main important column here. So that so if a user interacts with the chatbot, they input the query. Test data creation. Looking at the Python script, just to give you an overview of the parts of the script, we have some random functions for creating a random date. a random status string, and a random severity, random phone number, and yeah, these are for the creating random dates. These are helper functions. And then we have some template sentences for creating the incidents. So what we are going to do is we have the template sentence with parameters in it, and we will substitute the parameters, or we'll keep changing the parameter to create a random text for the incident description. And then there is root cause. These are all sentence templates with parameters in them. We just replace the parameters with some values to create the test data. Generate user queries. This is the function. This will generate the user queries. If we go back to the schema here, we have 4 tables here. So I have one function for each table for creating the test data. So first we have the generate user queries. This creates the test data for user queries table. And then there is generate users and generate random incidents. And we already have generate categories over here. Okay, so just to show you the code in Visual Studio here. So this is the code that creates incident data. It has the we are importing pandas, we are importing these libraries, pandas, random, and datetime. So this random date is actually from this library, datetime, and it uses datetime dot time delta. This is the library call. And then there's a random phone number. This is random int that we are using, random dot randint. And then random status, random severity. We are using random choice. So it's between these choices that we are going to choose. And here it's between high, medium, low. And then, of course, we have a random date that uses time delta. Again, it's a repetition of this. So generate categories. What are we doing in generate categories? I have some hard-coded values for categories and subcategories. I have some objects created for representing the categories and subcategories. It has category ID, category name, and subcategories array, which has subcategory ID and subcategory name in it. Right, and then category list. So this is the list that's going to it's going to flatten this JSON object, and then it's going to create a simple entry for each of the category and subcategory combination. And we are going to create data frame. Data frame is part of pandas library. And these are the template sentences that I was talking about. So we have these 3 sentences, for example. User reported, and then subcategory is the parameter. Issue on the website causing poor user experience. So we have 3 different, I'm using 3 templates. And then root cause templates. It's a similar concept. Root cause templates, resolution templates, solution templates. And then for generating the user queries, I'm using query templates. After we generate the data, we can go over it to see how it looks like. And then, so I'm mostly using data frame from Pandas library for storing the data. And then finally, after I've gone through these functions and created the data in data frames, um, what I'm doing here in the main function is I'm writing all the data frames into a CSV file, into individual CSV files. So we have 4 CSV files for each table, one for each table: users table, categories table, incidents table, and user queries table. All right, so let's try to run this. And this program is going to create 4 files, 4 CSV files, in the same directory as where the Python script is. So these are the 4 files that got created today at 9:44 p.m. Categories table, incidents table, and user queries table, and users table. Okay, so let's separate them and store them as data files here. I've created a separate folder here. Let's store all the 4 files here, and then going through these files here, we have categories table, and okay, let's go through the categories that I have chosen. Website performance, let's say that's an incident category. And it has subcategories: slow page load, server downtime, high response time, CDN issues, caching problems, image loading issues, broken links, CSS loading, CSS not loading, and JavaScript errors, website performance, third-party script issues. And the next category of issues would be checkout failures, and we have 10 different subcategories for checkout failures. So these are the subcategories under checkout failures. And then user authentication issues. And we have again 10 different subcategories under user authentication issues. Looks like there is a duplicate. We may have to get rid of that. So that it doesn't cause a problem later while inserting the data into the database. Okay. And we have 10 categories, and each category there are 10 subcategories. So this is the table that has all the details of the categories and the subcategories. And then let's look at the users table next. So users table is nothing but, so the L1, L2 engineers are the users of this chatbot. So it's their details that are, those are the users that will be interacting with the chatbot. So it's their details. We have name, email address, their role, phone, department, and created at last login. So just a random, at random, I have created 10 users here. And then let's look at the incidents table. So the script has created about, I think I have coded it to create about 3,000 records. Let's check. Yeah, it has created 3,000 records. And in this table, we have incident description, root cause, resolution, solution, how the incident was solved or how the issue was solved. And then we have the subcategory ID, and then created at, updated at, so this column allows nulls, and the severity. So just to look at an example, so this is an incident ID. Frequent slow page load was observed requiring immediate attention. Root cause identified as a slow page load, related configuration issues. And then resolution was patch the underlying slow page load component to restore functionality, and the solution was to implement a new cache strategy for slow page load to reduce the server load. And then, so that's one example. Another example, if we randomly picked, it's frequent email confirmation error was observed requiring immediate attention. Issue traced to a faulty email confirmation error system. Fixed the problem by updating email confirmation error configurations. And then solution was to applied patches to the email confirmation error modules, improving stability and performance. So that's the incidents table. And then users queries table. For example, what is the status of my incident related to frequent tax calculation issues requiring immediate attention? I need more information about frequent third-party script issue requiring immediate attention. And then why is the website experience JavaScript errors leading to significant drop in performance, issue taking so long to resolve? So there are some random errors in these sentences. We are going to use this data for training the ML model. We have to see how it goes. So that's about the test data creation. Okay, let's look at how we can upload this data into SQL DB. So first I'm going to create the SQL DB manually and upload it. And then next I'm going to show you how how this can be automated, creation of the infrastructure, and like provisioning the infrastructure and also uploading the data, both automated. So let's go create a resource and then SQL DB. Yeah, SQL database. And then start with creating a new resource group. Enter the database name. Okay, the database name is available, and create a new server. I'm going to use SQL authentication. So SQL admin login. I'm going to give something like a SQL admin. I'm going to create the password. Just so that I remember, I'm going to make a note of them here. Okay. Okay. Let's look at the details here. Do we have all the details? Allow Azure resources. This I want to change. I want to change it so that I can allow the resources and also make it a public endpoint. So let's go to the previous step and let's go to networking. Going to make it a public endpoint and allow Azure services resources to access this server so that because we are going to upload the data. So add current client IP, which is my local machine. Allow that to access. Yeah, and then create. Okay, so while the resource is getting created, I want to show you this tool called Azure Data Studio. So this is a tool that connects to Azure where which we can use to upload the data. And also once the data is uploaded, um, we can view the data. Okay, so the deployment is complete. Let's go to the resource. You can use this as your data studio to connect to the database. Um, This is the previous. Oh, this is my local Express edition. Let's add a database here. And then, so East US SQL DB and East US SQL Server. So let's clear the list and then let's refresh this list under my subscription. Yeah, so East US SQL Server, East US SQL DB. This is what we are going to connect to. East US SQL DB. And then the authentication type that we set was SQL. Username SQL admin. And password admin. And then let's try to connect. Yeah, so for now we don't have any tables. We can add a table. Mhm. Okay, let's do it through import wizard. It's saves time. So let's open the import wizard. And this is going to import a flat file and it's going to create the table. Mm. Yeah, this is the data. It looks good. And then let's set the primary key, subcategory ID as the primary key. Import. Successfully done. Okay, let's use the import wizard to do the same thing for 3 other tables. Incident ID is the primary key for us here. Import the data. Done. Can we import multiple tables? No, we can only import one table at a time. Okay. Incident ID is the primary key here. Okay. Go to wizard. Last one. Let's check if okay, refresh. Yeah. So columns. Yep. Okay, let's select top 1000. Yeah, categories, category 100, 200, 300, 400, 500, 600. Yeah, all the categories are here. Looks like the data is here. Yeah, it's nice. Let's go ahead, refresh here. And check if the data is there on Azure. I know it shows in the Azure Data Studio, but also check from Azure portal. Let's check the query editor. Yeah, tables. Yeah, our tables are all here. New query. Select top 1000. Yep, there you go. Okay, so incidents table. Let's actually query this. Select top 1000. Then run the query. So let's check the CSV file and compare a couple of rows quickly. Okay, so incident ID 22340. There's the 22340. And then it was reported by user ID 9. And then user reported broken links issue. Uh, user reported broken links issue. Yeah, it's the same row. So we have the data. Mm, okay. So so let's try to create the same thing with the Python script. Oh, yeah, so the Python script does start from scratch. So if the resource group is not already there, then um, then it will create the resource group and it will create a firewall rule. So to check the Python script, it's going to first we are going to run the provision SQL DB Python script. This is going to create an instance of the SQL DB in Azure. Let's start from scratch. Let's get rid of the resource group here. Because yeah, it's going to create the resource group. Okay, let's delete the resource group. Yeah. While that is getting deleted, let's go through the Python script. So we are importing these libraries: Azure.identity, Azure.management.resource, Azure.management.sql, Azure.management.sql.models. All these four libraries are for infrastructure, for creating the infrastructure on Azure and managing it. So I'm giving my subscription ID resource group that I'm going to create. I'm going to create it in East US location and SQL Server name and the SQL database name here. So default as your credential, it's going to create the credential based off of my subscription ID. And then I'm going to create an object of resource management client. And with the resource management client, I'm going to create the resource group. And then I also have the SQL management client. Using that client, I'm going to create the server and the database. It's still deleting the resource group. So yeah, the resource group is created. I think the DB is getting provisioned. So script is still running. The server is created. The database is being provisioned. All right, it's done creating the server and the DB both. So let's go check. Refresh. Yeah, so that's the database. Now we can run the data upload Python script for uploading the CSV files and creating the tables. Let's look at the functions that we have here. So first, let's change the server name and the database name, and make sure the login matches. So SQL Server East US, that's the server name we created. Yeah, it's same server here. And SQL DB East US, SQL DB East US, and then the SQL admin and admin password. SQL admin password, okay. And first I start off with creating a firewall rule so that uh, uh, my machine, my local machine, has access to the SQL DB on Azure. Um, and then upload data to SQL. So we are using the ODBC driver for uh, uh, creating for accessing the database and creating the tables. And we have the create table statement over here. Um, this is for the users table, and then this is another query for adding a column, and this is insert statement for um, inserting the rows into the table, and we go one by one. We upload one table at a time using the CSV file. This is the file path. Um, File path is actually this one. So just for sample, I'm showing only one table in this demo. We have already seen how to upload all 4 tables from the Azure Data Studio. Just to show the Python script automation, I'm going to demo one table upload. So adding firewall rule, allow my IP address, firewall rule it doesn't already exist, so it has created it. Firewall rule added successfully, data imported successfully. And then just I was testing this script, so I added these removing firewall functions as well, but they are not very important. Um, just to test whether it creates, if it doesn't exist, I have these functions. Anyway, let's go ahead and check our database, how it looks like. We added a table, so it should have created a table over here. Query editor, SQL admin, just double check the credentials. SQL admin and admin password. Let's actually admin password. I'm not sure about. We may have to change that. So use that. Login. Mm, yeah, it has created the DB users table. ID, name, email, role, phone, department created at last login, and then select top 1000 rows. Run the query. Yeah, we have all 10 rows. So that was the automation to upload the data into SQL DB on Azure. And then for destroying the SQL DB, we can use either Python script. For using Python script, you could just uh, resource groups dot begin delete. This would delete the entire resource group. And or you could use a bash command. Azure SQL DB delete is the command, and it takes the resource group server and the name, the database name, and it takes a confirmation whether it takes a confirmation whether you're sure about deleting the database. This one is actually a delete command for the deleting the entire resource group. I'm going to go ahead and delete this manually. It's simple and straightforward. Or I could use the bash shell on Azure. Yeah. Yeah, so the DB is deleted. Sorry, I was mistaken. So this command deletes the database. Let's go ahead and manually also delete the server from here. And then I'm going to keep the resource group because I'm planning to create a Cosmos DB and upload the data into Cosmos DB as well. Uploading test data into Cosmos DB. This I'm going to show you manually today. The steps involved are create a Cosmos DB account and then create database and container in the Cosmos DB and then convert CSV files to JSON files. Yeah, this is another, since Cosmos is a NoSQL DB, we have to use JSON files to upload the data and then upload the data using upload the data from the portal into Cosmos DB. Okay, we already have the resource group. I'm going to go ahead and create Cosmos DB as your Cosmos DB. You can either create a Cosmos DB for MongoDB or a NoSQL DB. So I'm going to create using, I'm going to create a NoSQL DB. Enter an account name. To create it in East US. While the Cosmos DB is getting deployed, I'm going to run a script to convert CSV files into JSON files. You're gonna do one by one. First, I'm converting categories table into a JSON file. Okay. It would have been easier if we could view this in Visual Studio Code. So we could probably just drag and drop it here to see the file. Yeah, here there's category ID, category name, subcategory ID, and then similarly that. Yeah. And next I'm going to do the same for incidents table. Okay. Wow. So do we have all the 3000 records? Yeah. Looks like it. So the last one, users table. So we have all the JSON files to be uploaded into Cosmos DB. Go to resource. And then create items container. In the containers. So we have to go to the data explorer. Where's the data explorer? And so by default, this is the database created. To create a new container. Yeah, name it as incident DB. This is the DB we created. We can actually get rid of this. Yeah. Okay. Upload item. Select the JSON files. This is going to read the file. Our latest files are here. So I'm going to choose all 4 files and upload them.
This is the last activity, right, in the demo?
Yeah, this is the last activity. Yeah.
Okay.
Okay, so it's done. Mm. We select star from C. C is the collection here. So let's see if I have the collection. Yep, we have the collection. And let's actually query for something specific. Sorry. Where category name uh, is equal to website performance. Or category ID is 100. Let's we could also do one thing. We could query ChatGPT and find out how we can
What happened for the Cosmos DB?
So I don't exactly remember the syntax of submitting a specific query with the where clause here.
Okay, okay.
I remember doing it previously, but for some reason
Yeah,
it's
yeah,
not
you
working.
can use the ChatGPT, no problem.
Yeah. Oh yeah, this is what I was missing. Where C dot incident ID is equal to, yeah, let's say C dot incident ID. Yeah. So we have two incidents with that incident ID. Oh, actually, it's a query. One entry is from the query table and the other entry is from the incident table. And then if we go back, and if I say I want to see C dot category ID equal to 100. Okay, so category ID is 100 and the various subcategories under it. 102, 103, 104, 105. And then so I want to get everything. I want to get all the records where user ID is 8. Yeah, so this is all the incidents. All the incidents handled by this user whose user ID is 8. We have well, we have 100 records, I guess. No, we have more than 100 records. Yeah, 310 records. All of their incident IDs is, oh, sorry, user ID is 8. Yeah. So that's our demo today. And then lastly, how to destroy a Cosmos DB. This is the bash command. Let's try it from Azure Bash shell. Cosmos DB account name. It's the account name. The resource group. In the next phase of the demo, we will probably be looking at the how to use Databricks for ML modeling, and we'll be using the same data for model training.
We'll discuss offline on the tasks.
Okay.
Now you destroyed the database for SQL DB
Yeah, SQL DB database is destroyed. Yeah, and I manually
and
destroyed the.
Cosmos.
Yeah, now it is running Cosmos DB destroy command or the delete command.
Okay. Okay. So you showed the commands also, right? Okay, fine.
Yeah,
Now what we'll do, we'll stop this recording. It is a long demo among all of your demos, past demos. I
yeah,
think this is the longest.
yeah,
Am I right?
yeah. This is the longest. Yeah,
Yeah, it involves test data creation, then uploading into database, two different databases with manual efforts and automation efforts, all those things. You showed
yeah.
the automation and manual also in this area. Okay.
Yes,
Right.
yeah.
I'll stop. Shall I stop recording? You
Yeah, we can stop recording. Yeah.
okay? Right.